All right, in our second example in section 3.7, we're going to continue writing equations of lines. It says here in example number 2 to find the equation of a line with the given information. Write your answer in slope-intercept form. So our final answer needs to be y equals mx plus b. It says in part A, find an equation of a line that's parallel to 3y equals 3x plus 12 and has a y-intercept of 0, 5. Now, if you remember from slope-intercept form, we need a slope and we need a y-intercept. And they gave us a y-intercept, but we're kind of missing a slope, aren't we? The only thing that it tells us is that it's parallel to this line. Ooh, but what do we know about parallel slopes? Hopefully, from a previous section, you remember that parallel lines have the same slope. So if I can figure out what the slope is of this line, then I know the line that I want is going to have the same exact slope. So let's figure out what the slope is of this line. I don't know what it is yet, but if I can make it look like slope-intercept form, y equals mx plus b, I can easily pick out its slope. So let's do that. I'm going to take that equation. I'm going to divide every single term by 3, and I end up getting the equation y equals 1x plus 4. Now, I don't care about his y-intercept. I just want to use the slope. And since I know that the slope of the line I want is going to be the same as this slope, I want to use the slope of 1. So if I have a slope, which I do now, my slope is 1, and I have a point, in this case, I have a good point. I have the y-intercept, the exact point that I need in order to be able to make it look like slope-intercept form. I can plug those two numbers in to my equation. So my equation for this line that's parallel to the line 3y equals 3x plus 12 and that has a y-intercept of 5 is the line y equals 1x plus 5. I needed to find the slope, and I used the y-intercept to plug those numbers into my equation. Let's do another one. B says, find the equation of a line that's perpendicular this time to the equation or the line 3x minus 4y equals 7, and that passes through the point 9, 2. Ooh, in this one, they don't give us a y-intercept this time. This time they just give us a point. But they do give us a point, 9, 2. Do they give us a slope? Not really. They give us an equation of this line, and it says that the line I want it to be perpendicular to that. So do you know anything about perpendicular slopes? Hopefully you remember from last section that perpendicular slopes are opposite and reciprocal. So if we can find the slope of this line that they give us, we can use the opposite and reciprocal for the line that we want. Let's do that now. I'm going to take the equation that they give us, and I'm going to make it look like slope-intercept form, y equals mx plus b, so I can find easily its slope. I'm going to subtract 3x to both sides. I'm going to divide every term by -4, and I ended up getting the equation y equals 3/4 x minus 7/4. You notice that the two negatives made a positive, and now I can easily figure out what the slope of the old line is. Be careful, don't use the y-intercept of this old line. I want a new line that passes through the point 9, 2. So I don't want to look at the old line's y-intercept, I just want to look at the old line's slope. But be careful, we don't want to use the same slope. We want our line to be perpendicular to this line. So we want opposite and reciprocal slopes. So if the slope of the old line was 3/4, what's the slope that we want to use? Yeah, -4/3, right? So now we have the two things that we need. We have a slope, -4/3, and a point, 9/2. Now that we have a slope and a point, do you remember point-slope formula from the last video? We can go ahead and use the point-slope formula to find the equation of this line. Let's do it. Let's plug in our point and let's plug in our slope and figure out the equation of this line. I have a y minus y1 equals m times x minus x1. I plugged in my 2 for my y, I plugged in my 9 for my x, and I plugged in my -4/3 for my slope. I'm going to go ahead and distribute the -4/3 through. I ended up getting the equation y minus 2 equals -4/3 x plus 36 over 3. If you put it over 1, two negatives make a positive. I get -36 over 3, which is really just positive 12, right? I can go ahead and add 2 to both sides so I can make it look like slope-intercept form. And I ended up getting the final equation for the line that's perpendicular that goes through the point 9, 2 as y equals negative 4/3 x plus 14. Now be careful. A lot of students forget they're talking about perpendicular and they end up accidentally using the same slope. So make sure that you're paying attention to what it's asking you to find. Is it asking you for parallel or perpendicular? And then make sure that you use the appropriate slope, okay? All right, I want to do a couple more with you here. It looks like on C, it asks us to find the equation of a line with a slope of 1/2 that passes through the point 8, 3. Remember, there's two things I need for an equation of a line. I need a slope and I need a point. Oh, well, looks like it gave us both of those already, right? It gave us a slope of 1/2. We didn't have to do any work this time. And the point, 8, -3. So let's go ahead and use our point slope form, plug in our values, and simply find the equation. I have a y minus y1, be careful with those double negatives, equals m times x minus x1. So your point slope form should look like mine. These two negatives make a positive here, and I ended up with y plus 3 equals 1/2 x minus 4 after I distributed the 1/2. I can subtract 3 to both sides, and I end up getting the equation y equals 1/2 x minus 7. He has a slope of 1/2, and he should go through the point 8, -3. That one was too easy. Let's do a couple more. D says find the equation of a line that passes through the point 6, -1 and the point -2, -3. Now remember, there's two things I need to write the equation of a line. I need a slope and I need a point. Well, they didn't give us a slope this time. They only gave us 2 points. But I have the second thing that I need. I have a point. I actually have 2 of them, right? But I am missing a slope this time. So how are we going to figure out what the slope is if all they give us is 2 points? Well, do you remember that there's a slope formula? y2 minus y1 over x2 minus x1? Can I use that slope formula to figure out what the slope is between these 2 points? Let's do that. So I have -3 minus a -1 over a -2 minus 6. I ended up getting -2 over -8, which can be simplified into positive 1/4. So now I do have a slope. I have the slope between these 2 points as 1/4. The next thing I need is a point. Remember, they gave us 2. So here, you can pick either one of the points as long as you make sure that you pick the x and the y of the same point. You can use either point and use the point and the slope to plug it into point slope form. We should all get the same answer no matter which point we choose. I'm going to go ahead and just pick the first point. I'm going to plug in the y, I'm going to plug in the x, I'm going to plug in my m, and I'm going to find the equation of this line. I have a y minus y1 equals m times x minus x1. I'm going to go ahead and distribute the 1/4 through, and I ended up getting y plus 1 equals 1/4 x minus 6/4. I can go ahead and subtract 1 to both sides, but you notice that I have fractions here, and in order to be able to add or subtract fractions, I need a common denominator. So that's what this -4/4 means. -1 can be converted into -4/4. So now I have common denominators, and I can add my fractions together. I have a -6/4 minus a 4/4, which really gives me a -10/4. Let's go ahead and reduce if we can, though. And I ended up getting the final equation in slope-intercept form of y equals 1/4 x minus 5/2. Okay, last one. E says find the equation of a vertical line that passes through the point 2, 8. They give us a point on this one, 2, 8, but I don't know if it gave us a slope, did it? It doesn't give us another point. All it says is that this line is going to be vertical. I know that a vertical line looks like this. Do we know what the slope of a vertical line is? Well, hopefully you do. Hopefully you remember that the slope of any vertical line is undefined. The problem is we can't really plug in an undefined into our point slope formula like we've been doing when they actually give us a slope. So this one's going to be a little bit different. Maybe we can kind of imagine what this graph looks like, and maybe that will help us figure out what its equation is. I know it's going to be vertical, and I know it's going to go through the point 2, 8. So maybe we can kind of sketch the graph. I know it's going to be vertical. And I know it's going to be through the point 2, 8. So I did a quick sketch of this graph. I noticed that this graph touches the x-axis at 2, 0. And it's never, ever, ever, ever going to go over there and touch the y, so it's never going to have a y equals. So do you remember what an equation of this line would look like? It's going to be x equals 2. It's going to touch the x at 2 and be a vertical line. Any vertical line has the equation x equals, and then the x value of its intercept. All right. Make sure that you practice all of those different things. I know that was a lot in this video, so make sure you practice all of those different ideas. Writing equations of lines is really important. We're going to be doing this a lot in other sections and in other classes from here on out, so it's important that we know how to find a slope, find a point, and be able to put it together to write the equation of any line.